Here's a video discussing how to make descriptive statistics, or sorry, how to make figures in R, and kind of finishing up descriptive statistics, variability, that kind of stuff. So for this lecture, it will help if you download this R code. So you want to download that. For me, it's just opening right up in R automatically. That's handy. You're going to want to download this CSV dataset, the Duncan dataset. We use that in class. You can download the PowerPoint if you want. And then this is also a CSV file that we'll use in this little lecture. So these are the kind of the roadmap, the things we're going to cover today: how to compute variance in R, how to do a pie chart, a bar chart, a histogram, a scatter plot, a box plot. And at the conclusion of all of this, I'll have some more advice for you, because I know all of you crave advice from me. So first, let's look at pictures of how distributions can differ. In this figure, distribution A, B, and C all have the same mean, they all have the same high score, and they all have the same low score. But because distribution C is more spread out, it has higher variation than distribution A or distribution B, in which the data are more tightly put together. Each of these distributions would have the same range. That is why the range is a weak descriptive tool. We like to use the standard deviation or the variance to describe it, because as you can see from these pictures, even when you have the same high and low score, you can have a very different distribution of responses. There's skewness that you could have in data, right? So distribution B is not skewed at all, but distribution A, you have kind of more responses over here than over here, and here you have more high scores and low scores, so that have a negative skew to it. So variability is, when we talk about variability, we're trying to talk about ways that we can measure how spread out scores are, or dispersion's another word for that. There's three ways you can measure that statistically. The range, which we'll talk about in a second, the standard deviation, and the variance. So the range is just the highest score minus the lowest score. Right? So if in this data set, the highest score is 98, the lowest score is 48, 98 minus 48 equals 50, that's the range. But you can see why this could be a problem, right? Because distribution C has the same range as distribution A, the highest score minus the low score. But they have very different variability in those distributions. So we use the standard deviation instead. It gives you a measure of average dispersion of data. So the standard deviation is the sum of each value of x subtracted by the mean squared, add those up, divide them by n minus 1, and take the square root. I'll show you as an example. Let's say that you had this data set. Let's say that my kids, I pay them $5 a month in allowance. And they come to me and they say, "Hey, Dad, my friend makes $8 a month in allowance. You're ripping me off." And I say, "Well, let's find out. Why don't you go around the neighborhood and ask all the kids what allowance they get?" And so then we would say would be the distribution. My kids are here at 5, right? But there's some kids at 8. There's a kid at 3. And we want to figure out, is it true my kids are getting ripped off? You might remember from some of your other statistics class or experiences in math that the standard deviation, if you go one standard deviation above the mean, 67% of all values are within one standard deviation of the mean. And if you go within 2 standard deviations of the mean, 95% of all values are within 2 standard deviations of the mean. So this is a great opportunity. We could figure out what the mean is and figure out if my kids are within 2 standard deviations of the mean. And if they are, I could say, look, you're statistically fine. So that's the first thing we do is we compute the mean. We add all of these scores up. We get a total of 60. The sample size is 10. So we divide 60 by 10. We get 6. So these values are the mean allowance values, right? So my kids might say, hey, Dad, I'm only getting $5. I'm below the mean. And I say, but I want to know if you're significantly below the mean. Are you enough below the mean that we should worry about it? So then what you do is you take each score and subtract from that the mean. So 8 minus 6 is 2. 8 minus 6 is 2. This should be 3 minus 6 is negative 3, but whatever. 4 minus 6 is negative 2. If you did that and just added them all up, you'd get 0 every time. So in mathematics, we know that if you square something and then take the square root, it's mathematically the same, right? So what we do is we take that, 2 minus 2, square it, and we get 4. 2 minus 2, square it, and we get 4, right? 3 times 3, negative 3 times 3 squared is 9. So then we add all these values up and we get 28. I take 28 divided by my sample size minus 1, which is 9, and I get 3.11. This value right here is the variance. But we're not done. You take the square root of that to get to the standard deviation. So the variance and the standard deviation are basically the same thing, except for that the variance is in squared units. Why would that matter? Well, again, I told you about the 67, 95, 99.7, all that stuff, right? So if I'm talking about whether my kids are significantly below the mean and all I'm doing is looking at this variance number, that's in squared allowance dollars per month. That's a very weird thing, whereas this is in dollars per month of allowance. So that's why we square root it and use the standard deviation. So that means that if my kids get 1.76 below the mean or 1.76 above the mean, they're within that normal range where about 68% of people are, right? And so what I could do is I could go back to this and say, okay, you get $5 of allowance, but 6 minus 1.76, which is the standard deviation, gets me to 4.24. So technically, I could lower your allowance to $4.24, and you would still be within one standard deviation of the mean, which is where the vast majority of people are. Your friends that are getting $8 of allowance, they're above one standard deviation above the mean, right? Because 6 plus 1.76 gets us to 7.76. So your friends are just very unusual values. Your friends are on the high end, the equivalent of this kid who's getting $4 of allowance on the low end. So rather than saying that I should move you up to be like these kids, I should move you down to be closer to that kid. But not exactly there. I should just get you to 4.24 and you'd be fine. And then my kids would say, you're so cheap. In R, it's way easy to calculate that, right? If I read in my data set, I forgot what I called that data set, but I'll just type it in down here. If I go D1 equals CSV file dot choose, and then I choose that dispersion class, right? So this is now I've got that same data set. If I just type in standard deviation of the variables called x, and I get 1.76. So much easier to do this in R than to calculate it by hand. If you have a standard deviation of 0, that means there's no variation. All the scores are the same. So the variance is just the standard deviation squared, right? It's the same formula. You just don't take the square root. And you can do that in R by typing in the command var, and then it gives me that same value. So this slide is something we already talked about in the example. So I don't know that I use the standard deviation stuff very often in my life, but it's good for you to sort of get comfortable with standard deviations and how they're used. And more important, it's best for you to get comfortable using R. Okay, so now let's talk about how to make pictures. Pictures are not great in R. There are certainly better places to make figures, but I like to teach you how to make figures just because it becomes a useful skill to have for helping you learn to use R and kind of get used to working with data. So first we'll use a pie chart. The first two charts we're going to use, you use when you have a categorical variable. Now, categorical variable means that the variable is words, right? So you could think of like gender where it's male, female, or you could think of party identification, or in this case, it's going to be like blue collar or white collar job. You can't just make a figure of words. You can't do that in any software. It just makes just stacks a bunch of words on each other. That's no good, right? You could maybe try and do a word cloud, but that's not very beautiful either. So what you do is you make a table that shows you how many people fit into each category, and then you make a picture of that table. So I'm going to use the $ approach in the way I do it, but you can do it however you want. So first we have to read in the Duncan data set. Let's see if I have R code in here that does that. I suppose there's that code. I'll just do it again, right? That file choose thing. And I'll just choose the Duncan data set this time. So in the Duncan data set, here I have the row number, here's the career name, here's the type, professional, white collar, so on, and then some numbers for these other columns. So if I want to make a pie chart of education, first, well, I can't because it's a number. So that's kind of silly. Let's do it with type instead because that makes sense. So the first thing you have to do is make a table of D1 $type. So I see that I have 6 white collar, 18 professional, 21 blue collar. And to make a pie chart of that, I just put a pie command around that. And then it gives me this beautiful looking pie chart. Honestly, that's so ugly. The reason I don't like pie charts is because this could be 6, this could be 18 and 21, or it could be 600, 1800, 2100. You see the relative proportions, but you don't know how many people fit in those categories. So I don't like it when somebody does a survey and just shows me a pie chart because I don't know how many people took the survey. If you do it the right way, with a bar chart, then people know exactly how many people took the survey and how many people fit within each category. Business people love this for some reason. For some reason, business people don't seem to care about how many people are in each cell. But it matters to me. I like to know the sample size. So to do a bar chart, instead of doing pie, you just type in bar plot or something like that. And now you get, right? Now I can see, okay, it's 21, 18, and 6. You could spend a lot of time making beautiful bar plots. In fact, in graduate school, I had to, for one of my exams, make amazing looking bar plots. I had shading in here, words in here, I changed stuff. It took me 20 hours to get these beautiful bar plots. And then I forgot to save the code, and I don't have it anymore, and I have no inclination of trying to make beautiful bar plots. To be honest, if I need to do pictures with categorical variables, I do them in Excel because Excel is just an easy place to do that. But for the rest of the charts we're talking about, it's actually easier to make them in R. So the next one we'll talk about is if you have one number, a column of numbers, right? So this one here, let's say it's education. How are you going to make a beautiful figure that shows the dispersion of education? Well, in Excel, to do the histogram, you have to create your own bins, and then it'll fit numbers within those bins for you. But in R, you just type in the histogram command, and you tell it the name of the variable, and then it makes it for you. And you can say, wow, that's awesome. And that, right, those labels aren't so great, but I can easily see the distribution. I can see this sort of bimodal I can see the maximum value, the minimum value. It's really easy to do these in R. If you use the code that I have here, you see that you can change those labels for income, right? This is an income example where you get rid of the main title by just putting blanks in the main, and you change the label for the x-axis by just telling it that it's that word. So you can make really beautiful histograms really easily. What if you have two numbers? Again, two numbers. Let's say you wanted to know if there's a relationship between income and education. That's not so easy to do in Excel, but in R, piece of cake, right? Just plot those two variables against each other. You get this nice scatter plot. If you were doing a regression, you could, I know, I don't want to get ahead of you, right? I can make those labels nice and pretty with that part of code, where I just tell the labels, right? I can change what these dots, I can change them to the letter M if I want to. I could change them to whatever this symbol happens to be if I want to. I could make every dot have its own symbol if I wanted to by doing this, telling it to use 1 through 154, and then they all get their own symbol. Scatter plots are a piece of cake in R. And then probably the most useful thing in R is these box plots. They're awesome. That's if you have a numeric variable and a categorical variable and you want to see how things are different. So, like, what if I think that income varies as a function of the type of job you have? What if I think that, like, people in white-collar jobs make more than people in blue-collar jobs? Then I just do this box plot, and I can see, right? So here's the income values. Here's whether it's blue collar, professional, or white collar. The black line is the median. The box contains 50% of all the values, and then 100% of the values fit within these whiskers. So if you get a dot outside of the whiskers, you know you have an extreme value, unusual value. Sometimes people call these outliers, right? But what I can see is that the median income for blue-collar workers is much lower than the median income for professional, and white-collar has a median income lower than professional. And I can see that very few professional jobs make as little as most blue-collar jobs. Very few blue-collar jobs make as much as most professional jobs. And white-collar jobs are sort of truncated, right? The low end on white collar is not as low as the low end on professional, because there's no whiskers here because it all fits within this right here. So a box plot is a really helpful tool to see how the data are dispersed by categories, right? Let's say that I thought there were gender differences in something. I could put in gender and see, compare males to females, right? Or racial differences, I could put in that. And I could look at some numeric variable by race or gender, and I could see the differences. So box plots, scatter plots, histograms, I do a lot of those, and that's why I use R for those pictures. In Excel, those more kind of complex graphs are harder to do, and so I tend not to do those in Excel. I just use Excel for sort of the easy stuff. So let's just have a look at your homework real fast. Make sure that, yeah. Just remember, some plots are amazing, some are not worth your time. If you really want to get good at stuff, you got to practice. There are so much data in this world. I have just files and files of data. You should never have a shortage of data that you can use to practice. On iLearn, there's gobs of data there that you could use to practice making pictures. If I were you, I would just learn, just do it, and then save your code, and then you can just do it over and over and over again. You're not going to remember this stuff. I don't remember this stuff. I have to look it up almost every time I do it. So you shouldn't expect to be able to remember the code. Just save your code and use it. Sorry, I accidentally went to grades, which would be very bad because you're not supposed to see each other's grades. What I meant to go to was homework, so we could just have a look at the homework real fast. So here's the variability homework. So I want you to make a bar plot. I want you to make a box plot. I want you to calculate the standard deviation, and then I want you to make a scatter plot. And then the quiz, really, if you don't make the plots, you can still answer the quiz questions. So these are real data. It's kind of fun to use real data when you're answering questions. So I wish you all the best of luck on this homework assignment. Let me know if you have any questions. I'm on Campus Wire every week answering questions. Good luck.